Hey, what's up, guys? Welcome to my YouTube channel. So today I want to share this problem with you guys. So how many parts and both is playing cut by and nice. And yeah, I don't know, but yeah, whatever. Okay, and if you want to see more interesting problem, then you can check out my video list. Okay, and this problem you can check. You can change it into like generalize it into higher dimension. So you can ask how many parts at most and say in space and cut by in planes, or you can like maybe do it a hyperspace or how many hyperspace that you can cut by in hyperplane. Okay, so let's say we solve the first one. So basically, how many planes that or how many like the largest number is largest, how many plane cut by n line. Nice. Okay, so one easy right for example, let's say n equals to 2 is sorry, n equals to 2 is just 4 right? And n equals to 3 that we can just cut here. So it's 7. I think n equals to 4 that you can do this. You can try to do I think this with this one. So you can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. And the easy way to do this is that the easy way to solve this is just find this pattern. Okay, so there are more advanced way to solve it, but let's solve this by a simple way. So by pattern is that suppose you already have a lot here. Let's say you have n lines. So you add these n plus 1 line. Okay, you add n plus 1 line. Okay, once you add this, the next line. Okay, so next line should intersect with every line, right? Intersect with every line. So for example, if I add this, then I will separate this space into 2, and this space into 2, this space into this space into 2. So I will just add 4 into 11. Okay, right? I will just add 4. Okay, so that means that let's say if I denote f of n to be the number of it, then I can say fn plus 1 is f of n. When I add the next, I become n plus 1. Okay, so this is the recursion formula. And notice this guy's just n. So I would immediately find that f of f should be a quadratic. Okay, and subject to let's say f maybe I should use f2 is equals to 4. And then also you know f1. Okay, maybe you know f1 is just 2. Okay. Okay, so the goal is just solving f1 equals to 2, f4 equals to 4, and f of n plus 1 equals f of n plus n plus 1. Okay, and I know it's quadratic, so I can just n squared plus b n plus c. Okay, and I can easily solve it. So 2 is a plus b plus c, and I get 4 is 4a plus 2b plus c, and you can check this. Okay, but basically, finally, you can just easily get the results, right? F of a will be, let's say, I think it's yeah, you can directly solve it. Yeah, I think the solution will be 2 divided by n squared. Let's see. Plus n plus 1. Okay. So f1 is 2, and f2 is 4 plus 2, 6 divided by 2, 3, 3 plus 1, 4. And yeah, I think you can check this is true. Okay, so yeah, if you do n plus 1 square minus this will produce 2n plus 1. And so 2, yeah, 2n plus 1 and 1. So 2n plus 2, n plus 1, n plus 2. Yeah, let's check this. Okay, so my results will be this. Okay, so let's see if I do n plus 1, then I get n plus 1 squared plus 1 divided by 2 plus 1. So f of n plus 1 minus f of n will be just 2n plus 1 plus 1 divided by 2 is n plus 1. Okay, so we directly solve this problem. And one way to write f of n will be just choose 2 and choose 1 and choose 0. By the way, there's a meaning for so you can prove this is true. Yes, this is just easy to remember. There's a meaning for showing this f of n is correct answer if you directly use this formula. But this is somehow like a complicated way, I think. So I would not introduce this idea in this video. Okay, so now let's solve the general one. Okay, so now I want to solve the general one. Okay, so I want to solve the following. I want to solve that if I have n maybe let's say I have n hyperplane. So I will imagine that it's a hyperplane is d dimension. Okay. So you can imagine that the original d should be like original d I would say is like 2 dimension. Okay. I will imagine it's 2 dimension. Okay, so I should maybe I should do this. I should change my problem into this. So I should say that in general, I want to say that if I have n hyperplane and I put into d-dimensional space. So what I'm saying is that original is d equals to 2, right? And the hyperplane is 1 dimension. Okay. So imagine, see, this hyperplane should be d minus 1 dimension object. Okay. And the maximum number, the maximum number of the space. So I would say that this is the hyperspace. In the previous stage, just the space, but this space is basically also obviously is also d-dimensional. Okay. And the theorem, which is very weird, but we can prove this using mathematical induction, is the following: it's like n choose I summation. So n choose I from 0 to d. Okay, so previous one equals to d equals to 2, we get n choose 0, n choose 1 by n choose 2. Okay, and for d equals to 3, that is n choose 3, n choose 2, n choose 1, n choose 0. Okay, so in order to prove this, we need some basic idea. So maybe let's solve. Let me just solve d equals to 3 just for the convenience. So the answer, let's write answer here. So it's n choose 3, n choose 2, n choose 1, n choose 0. Okay, so the idea to solve is the following, right? So for like if n equals to 2, that you get the 2, right? You get 4, right? You can imagine that basically you get 2 planes. Okay, for n equals to 3, you get 8. And this is easy to think, right? Because this n equals to 3 is just your x, y, z, right? You have your x, y plane, your x, z plane, and your y, z plane, right? So separate into a space. But one way is that imagine this is the third plane, and third plane cut in here. Okay, so this third plane, this third plane, will intersect the rest planes with the shape, right? So their intersection is the small dimensional object, right? So in this case, their intersection is a line. Okay, it's a line, and you can see that their intersection shape looks like the same. Okay, so what is this? This is like the previous. This is F2. Okay, right? So each one of these will give you like one extra space. Okay, so this guy will be just 4 plus 4. Okay, so if I denote that, now I define this. If I if I define f of 2n to be the previous one, which is n choose 2, n choose 1, n choose 0, then I get my f3n basically is in this one. I get f of 3n plus 1 will be f of 3n. Okay. Plus the nth line, right? The nth line added. Okay, the nth line added will give me should give me f2 of n. And because the second, right? So I get this. Okay. Okay, so yeah, our goal. So yeah, here. So let's imagine that someone tell you this, and we just verify this just for the convenience. Okay, so we just do the verification, and hopefully this is easy for you. Probably not so easy, but you can check this is true. Okay, so let me just give the general proof. So general proof the following, right? So our goal is to prove theorem is that let's use f dn should be in summation of n choose I from 0 to d. Okay, and the recursion. So let me just write down the key points. So the general recursion will be the following. So your d, your nth hyperplane will intersect with the previous -1 hyperplane, and with the shape n minus 1 hyperplane with the small dimension with the hyperline. Okay, so this gives you the following recursion relation. You get f of dn equals to f of d n minus 1, the plus of f of d minus 1 n minus 1. Okay, and yeah, so this guy will generate this, right? Will generate this. Yeah, so you can usually imagine that in the d equals 3 case and n equals 2. I think this is the very the easy way that you can imagine this is true. Okay, so the rest we just prove this. Okay, you can prove that this. Okay, so the rest we just try to prove this. Okay. Yeah. So yeah, we just plug this into this, and then we check it's true. Then we are done. Okay. And maybe there's some boundary condition that you need to check, but I think this is simple that you can check this is true. Okay, so let's verify this is true. So what we wanted to do is just choose I from 0 to d. And we try to prove the following. We try to prove this is true. So it's I from 0 to d n minus 1 I plus I from 0 to d minus 1 n minus 1 I. Okay, so yeah, so this is the results. Basically, it's I from 0 to d. And let's do this. Okay, I write it as this way. I take I equals to maybe this is not best. Let me just write it as this. Okay, so how should we do? So let me just change this to be I minus 1. So I get from I from 1 to d. Okay. So I change this to be I from 1 to d n minus 1 I plus I from 1 to d n minus 1 I minus 1. But in this case that I need to add one term, right? So I just n minus 1 0. Okay. And so this one is the same as n choose 0 because this guy's 1, right? This guy's just 1. And at least 2, then I get I from 1 to d n minus 1 I choose I plus n minus 1 I minus 1. So these guys you can use a Pascal's theorem. So these guys basically n choose I. Okay, so you get I from 1 to d, n choose I plus n0. Combine everything, you get I from 1 to d. Just this, right? And choose I. Okay, so we should finish the proof. And yeah, so this problem is interesting that I think once you understand this recursion, that you can easily derive everything. And yeah, hopefully you understand these questions. See you guys in the next video.